Now, when we talk about percent change, and change is the only thing that is constant in this world, so get used to using change, percent change. We have 4 things that we have to be concerned about when something changes. The original amount of something, the final amount, after it changed. It either increased or decreased. Then we can find out how much it changed by, and then using all that, we can find the percent change, and we can write it as a proportion or as an equation. And then we're going to see some examples of that. So before we start, let's take a look at our regular percent change as a proportion. So remember, percent always goes over 100, but I'm going to write it like this. Percent change as a proportion would go over 100. Now, remember, in a proportion, the left side and the right side have to match. So if the left side is percent change, then on the right side, we need the amount of change. How much did it change by? And then we don't really have a total here because remember, in our other percent proportion, we had percent over 100 equals a part over the total. Because we're going to have 2 things that may be considered the total. But the original amount is what we're going to use, commonly accepted all the time. The original amount is the original total. Okay? So down here, across from the 100, that's going to be the original amount. In your science classes also, whenever you're finding a percent error, you're comparing it to the original measurement, not your final measurement. Okay. Now, percent change as an equation would look like this. So it would be good to write this down first before we go on. Right here. Okay. Percent change as an equation always starts with the original amount. Always. Then it's either going to increase or decrease. So I'm going to put a plus sign or a minus sign there because sometimes it's going to increase, sometimes it'll decrease. So you have to read carefully. Is something increasing or decreasing? If it's increasing, we're adding. If it's decreasing, we're subtracting. And what we're adding or subtracting is the amount that it changed by. Now, to get the amount that it changed by, that would be some percent. See, that's our percent change. Some percent of the original. Okay. So if you start with the original amount and then you increase or decrease by some percent of the original amount, then you should get the final amount. Okay. This would also be a good thing to write down, put that in your notes. It's always true. Always start with the original amount. So if something changes and you want to figure out percent change or use a percent change to find something, always start with the original amount. It's never a good idea to start at the end, well, unless you're working backwards. But in this case, we're not. Okay, let's see how we can use skipped one. Here we go. Percent change, markup applications. Adam's art store buys items for their inventory. One photograph was purchased for the wholesale price of $250. He marked it up 40% before putting it up for sale. Okay, what was his final price, the list price on the photograph? Okay, so you can solve this with a proportion or an equation, whichever you prefer. I think I'm going to use an equation because we have the original price. So this wholesale price is the beginning price that he paid for this photograph. So that is the original. So we're going to start with that. Then we're going to add or subtract. Now this one, we have marked the price up, so we're adding. Now when we add it, we're going to add 40% of the original price. So that's 0.40 times 250. And then that should give me the final price. Now we're also going to solve this one with the proportions so you can see how that goes. But in this case, all I have to do is multiply and add. So make sure you multiply 0.40 times 250 and then add the 250. So let's do that. 0.40 times 250 is 100. So that's 250 plus 100. So that should be a final price of 350. Now, if you did this as a proportion, okay, it might look something like this. The price was marked up 40%, so that's 40% to markup. Percent always goes over 100. The original price was 250. Now, what if I do it this way? What am I going to get here? What is that going to give me? So this is a hard thing with a proportion. You have to know, like, what is it that is returning to me when I solve this proportion? Well, if this 40 is a percent markup, right? That's the amount of the markup. If that's the percent markup, this is the amount of the markup. So if you cross multiply and divide this, that x should be 100. And then you wouldn't be done with the problem because now you have to go back to find the final price of the photograph and add that on to 250. So you still have to do 250 plus 100 to get 350. I should put a dollar sign on there. So that's why, see, sometimes in an equation, the work is done for you and you don't have to guess what you have and is there another step. All right, let's try the second one. The auto retail store bought a Toyota for $8,500. This typo, they marked the price up 35% to find the amount of the markup and the list price. Okay, this is very similar to the one we did before. They're asking us to find the amount of the markup and the list price. The last one, we didn't have to find the amount of the markup, but we did. So they bought it for $8,500, so that's the original price. They're marking it up, so we're adding. 35%, that's 35% of the original price. And here we can multiply, equals the final price. The final price would be the list price of the car. When you go to the car dealership, you are potentially paying the final price. Now, if we do the math in parts here, 0.35 times 8,500, I got 29.75. So that is the amount of the markup. So we found that. Add that to 8,500 to get your final price. 11,475. You might think, wow, they're making almost $3,000 on this car. But yeah, well, they're in business to make money. They're not in business to make you happy. Okay. Hopefully at the end of the deal, you're both happy. Let's try these. Some more markup applications. Yeah, I guess we can do these real quick. Sue's retail store buys small collectibles and gifts from the supplier. The one item she purchased for $1, she marks up to $2 before putting it up for sale. What was the markup rate? Aha. Now this one, since we don't know the markup, then in an equation, that would be our x. But I might tend to make this a proportion. We'll do it both ways, just to see. So they're looking for the markup rates. That is the percent markup. Okay, so we don't know the percent. In a proportion, that would go over 100. Okay? Now, on the other side, remember we need the original total on the bottom. That's 1. What goes on the top? Don't put 2 there. Remember, the x is the markup rate, so this has to be the amount of the markup. Amount of the markup. How much did she mark it up by? $1. You have to do a little subtracting there. Because she bought it for $1, she sells it for $2, so she marked it up $1. Oh, very interesting. If you cross multiply and divide on this one, you should get x equals 100. It's 100% markup. So when you double the price, it's 100% markup. Not 200%. When you double the price, you're marking it up 100%. Because you're taking the exact value that you paid for it and you're adding that on. That's 100% of the original price. You marked it up 100%. Now, as an equation, this would look like this. Okay, so the original price was $1. Oops, I almost wrote something else. So the original price was $1. Plus, we don't know the percent, but it's always the percent of the original price. See, that's a percent of the original price equals the final price, 2. If you subtract this 1 from both sides, you'll get x equals 1. And remember, that is the decimal form of the percent that we want. The decimal form of the percent is 1, so the percent is 100 because you're going to multiply that by 100 to make it the percent. Usually, if I have a missing percent, I like proportion better. Just personal preference. Like either way is fine. Let's try problem 4. Can you sketch the supplies always? And you can pause the video at any point in time, try the problem yourself, and then check it by pressing play again. Can you sketch supplies always use a markup rate of 75%? So we have the percent on this one. Kenny bought a certain refrigerator from his wholesaler for $8.50. What price is he going to put on before selling it? Okay, so this is very similar to the other ones. So he bought it for $8.50. He's marking it up, so we're going to add 75%, 0.75 times the original amount times $8.50 equals the final amount. So simple multiply and add. Okay, so I'm going to let you do that so that we can move on. Now, what if we are... What's the percent? Okay, so on number 5, we have another percent markup here. Tell you what I'm going to do. I'm going to suggest pause the video. I'm going to also pause. And then play the video to check your answer. Pause. Okay, so you unpaused and you're back. Did you get 47%? If not, check your workout. Okay. Did you use a proportion or an equation? If you used a proportion, did you put 200 over 425? Because that's the amount that you marked it up by. Okay, 47%. All right, let's try this number 6. Also, hey, you can do the same thing, but I'm gonna keep the video going though. You can pause. Okay, certain real. He has a markup rate of 35%. So he bought the bicycle from the store and paid. Okay, so this question is, what was the wholesale price? The wholesale price is the original price that the store paid. Then they mark it up and sell it to Brent for $3.35. So in this case, we don't know the original price. So we're going to start with the original price. Okay. X. And then it's a markup, so we're adding. 35%, so 0.35. Now that's 35% of the original price, but we don't know the original price, so it's 0.35 times x equals the final price. The final price that he paid for the bicycle, $3.35. Okay, so in this one we have an actual equation that we have to solve. This x for the original price is 1x, so that's 1.35x equals 335. And then we could divide by 1.35. So 335 divided by 1.35. $248.15. So this is a different one because we had a missing original price. So we always have to start with the original price, which means we're starting with x. It was marked up 35%, so we have plus 0.35x. And we can combine those like terms to be at 1.35x. Hey, if you think about it, whenever you mark something up, you're always marking it up above 100%. So if you're marking it up 35%, that's 135%. Interesting. Keep that in mind, because when we do discounts, we're going to do the same thing. Hey, let's do some discounts. So Jason bought a flat screen TV at the Walmart Thanksgiving Day sale. That's a big deal around here. It was 24% off the regular price of $298. Okay, so this is the regular price. Okay, and we're looking for the sale price. The regular price is the original price. Sale price is the final price. And we have the percent off. So let's start with $298. Now, this is a discount, so we are subtracting, not adding. Subtracting 24%, so see where it says off? Minus. Okay, 0.24 times 298, because it's always 24% of the original amount, equals the final price. We don't know the final price. All we have to do is multiply and subtract. Okay, so let's do that. 0.24 times 298 is $71.52. So he saved $71.52. Don't forget to subtract that from 298. $226.48. $226.48. Sale price. Okay. Joe got a great deal on TV too. The original price of his TV, the original price was $349. He paid $261. What was his discount rate? Okay, so here we don't know the discount rate. Do you want to use a proportion, or do you want to write an equation? Either way, if you want to stick with the equation because that's what we're using most of the time, then that's fine. The original price was $349, so start with the original price. It's a discount, so we're subtracting. We don't know the percent, so it's X times the original price, $349, equals the final price. He paid the final price $261.75. $261.75. So now we can subtract $349 from both sides. Notice we're going to get a negative number, but that's okay because we have a negative here. We have 349x, but it's negative because it was a minus. Okay, so now we're going to subtract 261.75 minus 349. 87.25. It is negative. That's okay because when we divide, we're going to divide by negative 349. And that should be 0.25. 0.25, which is 25% off. So that was Joe's discount. He got a better deal, 25% off compared to 24% off. Okay. If you want to see that as a proportion, that would be X for the percent off over 100 equals something over the original price, which was $349. To find out what goes here, that would be the amount that it's decreased by, the amount off. Because this is a percent off, right? Percent off. So this has to be the amount off. So you have to subtract, and the amount off is $87.25. Okay. Let's try one more percent change discount. Okay, Jim bought a computer for $425. This is what he paid. See, sometimes what he paid is going to be the original price, and sometimes what he paid is going to be the final price. Depends. So If he's a store owner and he paid that and he marked it up, that's the original price. If he's the consumer and he paid that, that's the final price. All right. The salesperson told him that $4.25 was 30% off. Okay, so this is his final price. And it was 30% off of the regular price. The regular price is the original price. What was the regular price of his computer? Okay, try it. Like, press pause, solve the problem, and then unpause to check your answer. Okay, so the regular price is X. It is a discount because it was 30% off, so that's minus 0.30x equals the final price of $4.25. X minus 0.30x. Remember, this x at the beginning is 1x, so 1 minus 0.30 is 0.70. And then you can divide by 0.70. 425 divided by 0.70. $607.14. Now, these final answers are all rounded off because they are dollar amounts, and dollar amounts can only go to the nearest hundredth. Please do not write for a dollar amount 607.142857 because we don't like count money out that way. It only goes to hundredths. 607.14. So hopefully you did well on that one. Hey, I just want to mention this. 30% off means you're paying 70%. Look at this. You're paying 70%. 30% off means you're paying 70% because you're taking 30% off of 100%. 30% off, leave 70% left to pay. All right. Here is a couple other percent increase and decrease problems. These are fun. I would suggest that you pause the video right now, pause, and then unpause and check your answer. So I'm going to do the same. I'm going to pause. Okay, check your answers to see how you did. And I have one more thing that I have to write here on this number 2, and that is the word billion. So when I did the calculations, I did not actually take 5.14 billion and turn it into 5140000000000. Because if I just keep the word billion consistent at the end with my answer, then I'm just carrying it through. It's like dividing both sides by a billion, and then at the end, I'm multiplying both sides by a billion to fix it, and it works out. All right, so hopefully you did well. Let's see what's next. Tax and sales tax problems. Well, one thing we hope you never have in your life is tax problems, but you should know how to compute sales tax and compute tax in percents. Okay, so let's try these. Jerome bought a bicycle with a purchase price of $398 in Tiffin, Ohio, where the sales tax is 7.25%. Oh, we should write an equation for these also. How much did Jerome pay in sales tax? What was the total amount of money that Jerome needed to make the purchase? Okay, so in sales tax problems, they all work the same way as percent increase and decrease problems. You have some original, like the amount of the sale, the original sale, I suppose, plus sales tax always add on. So we're just not going to put plus or minus. We're just plus. Sales tax is always add on. In this case, the percent tax, which is 7.25% in this case, of the original equals the final price. So it looks just like a percent increase or decrease problem. BRICE. Okay. All right, so in this case, he bought, the purchase price was $398. There was tax on it, 0.0725. Remember, you have to write the decimal form of that percent divided by 100 of 398, because it's always the percent of the original. See, it's the tax on the original purchase price should equal the final price. So let's take 0.0725 times $398. I got 28.855. We're going to round that off to 28.86. So how much did he pay in tax? $28.86. So then you have to add that on to your 398, which is $426.86. Okay. Number 2, Diego bought a new car for $26,525. He was surprised when the dealer then added this amount for the sales tax. What was the sales tax rate? Okay, now this one, we don't know the sales tax rate. Do you want to use a proportion? If you do, then you're going to put the sales tax rate over 100. And if you do that, the amount of the tax has to go across from the sales tax. And we have that, $2387.25, over the total amount, the original amount of the car, $26,525. Or if you want to write an equation, we can do it just like we did before. Okay, so if an equation would look like this, 26,525. Plus, remember, taxes always add on. We don't know the tax rate, but it's the tax of that percent of the original, 26,525, equals, in this case, after equal sign here, remember you need the final price. So you'll have to remember that the final price will be 26,525 plus 2387.25. We'll have to add those together, okay? 26,525 plus 2387.25 equals 28,912.25. 28,912.25. In either case, when we solve this, you should hopefully get the same exact answer. And I'm going to jump ahead here a little bit so we can save some time. And assuming that you're going to pause, check it, and then see if we got it right. It should be 9%. Pretty sure that's right. All right, check my work and see if that is correct. If it's not, please send me a message in chat or in Canvas. All right, let's try number 3. You earn $12 per hour at your part-time job. You worked 30 hours last week. Your paycheck was $259.20. What percent of your paycheck is being withheld for taxes? Oh, good question. Okay. So, $12 per hour for 30 hours. Let's do the math there to find the total earned. So, 12 times 30, that would be $360. Okay. They withheld $259.20. Wait, your paycheck was $259.20. We don't know how much they withheld. So the final amount was $259.20. How much did they withhold? Good question. Well, we can subtract those to find out how much they withheld. So 360 minus 259.20 should be about $100.80. Tell me if I did that right. $100.80. Okay. Now that I know all 3 of those, I can use a proportion. If you want to use a proportion, that would be the percent is our x over 100. And the percent is the percent being withheld. So across from the percent on the other side of the equal sign for a proportion, I need the amount withheld, $100.80, if I did that subtraction correctly. And the total amount is the original amount that the paycheck would have been if they hadn't withheld anything. That would be $360. And now we can divide and multiply to find that. 28%. So they're withholding 28% for taxes. Okay, so sometimes you have to do a little bit of math extra to get up to where you need to be able to solve the problem. In this case, we had to multiply $12 per hour for 30 hours to get the total amounts that you would have made. Okay? All right, I'm going to go on